Hey, this is Lucas Wilkerson. I'm FGCU's college algebra math coach, and this is just a review video that I'm recording that you guys can come back, look upon, and we'll be going over some of the questions that we go over in the math session on Tuesday evenings. So, anyone that I've highlighted is the one that I'm going to go over. Looking at question 1, plot the given point in the rectangular coordinate system. The first input is going to be on the x-axis, and the second input is going to be on the y-axis. So looking at -2, we're going to look at, I guess you guys can't see my hands, but there's the x on the graph and the y. So we just need to match them up. We'll see -2 right here, see +4 right here, and then we just plot the point. The blue point would be the answer. That's how you would just plot any basic point like that. So now for question 2, it says graph the equation. It doesn't require any method, it leaves it open to us. So moments like this, it's going to be easiest just graph some points. I recommend just, we're going to make something like this that keeps us nice and organized, which will be helpful when you turn in your work and get graded on it. So this is going to be, whatever we're going to plug in for x is going to go here. And we want to make sure we have both negative and positive values and the 0. That way we get a good distribution of points. So anytime you have to graph the equation like this, I just use those set of points, -2, -1, 0, 1, and 2. This middle row is just where we're going to solve the equation. We'll plug stuff in. And on the very right is just going to be the xy coordinate that we can keep track of. So we'll start by plugging in -2. -2 cubed is -8. -5, we get -13. So then we just draw the point -2, comma -13. Do the same thing for -1. -1 cubed is also -1. When you cube something, you're just multiplying it by itself 3 times. So it's like -1 times -1 times -1. All right, now we plug in 0. And 0 times 0 times 0 is, you guessed it, 0. -5 here. Let me not forget to draw my coordinates. And that's what we'll plot when we're done. We're going to plug in +1. And we'll get 1 here. We end up with -4. 1 comma -4. Now to plug in 2. 2 cubed is going to be 8 minus the 5, and we get +3. And now you can see we have enough points to actually plot this out. And so, just like how I showed us to plot a point in the last one, we're just going to look at each of these and place them on the graph. -2, -13 is going to be somewhere down here. -1, -6 right there. We have 0, -5, 1, -4, and 2, +3. Next step would just be to sort of sketch this. Make sure it hits all the points. Then we'll draw an arrow showing that it's just going out into infinity. So that's what your graph would look like, and that would be how you graph it. Okay, and number 3 right here is doing the same thing, but just with a different equation, so the graph would look different. So looking at question number 4, use the graph to determine the x and y intercepts. The x and y intercepts are just going to be observing the graph and seeing where it crosses on the x and y axis. So again, this one is, oh, no, I accidentally tried to erase it. This one is the x-axis, and this one is going to be the y-axis. So just to keep our work nice and organized, I'll write right here x intercepts, y intercepts. I'll just draw whatever they are right next to them. So look at this graph, we can see it intersects the x-axis actually at multiple points. Right here, here, and here. And by intercept, we just mean like when the graph is touching it. So we see it hits it at 1, hits it at -4, and it hits it at -5. So those would be our x-intercepts. And then for the y, just looking at the graph, it crosses the y-axis at that -4 down there. So that's all you do. You would just look for when it's crossing the x and y axes and just draw it out that it intercepts it where we showed for the x or we showed for the y. Alright, so for this question, we're just going to solve the equation, and to do that you have to find what x is equal to. But we can't do that how the equation is right now, so we're going to multiply some things out and hopefully it'll simplify. So we'll start with the parentheses. We'll multiply this -2 into the parentheses. Those are supposed to be little like arrows to show we're distributing them. Next, to keep it simple, we're going to combine the like terms, so the x factors and then just the constants together. And then we'll get, oh, not black, blue. There we go. Simplifies to this. Oh, not the eraser. Sorry, my Apple Pen's being weird. And then just like before, now we're just going to multiply these brackets. Put the -5 and multiply it. And we'll get 45x minus 25 equals -7x minus 4. And then to solve for x, we're just going to put everything on one side. So we'll add 7x. And we'll add 25 to get 25 to the other side. That will give us 52x equals 21. We need to divide by 52. We get x equals 21 over 52. Alright, so for the next question, we're still solving the equation, but instead of multiplying everything all out, we need to find a least common denominator. To find a least common denominator, we need to be looking for what both 5 and 9 can divide into. That is the least common amongst them. So in this case, 5 doesn't work for both of them, 9 doesn't work for both of them. But if you take 5 times 9, you'll get 45, and both 5 and 9 divide into 45 because we just multiplied the two together. So like 45 divided by 5 would be 9, and 45 divided by 9 would just be 5. So we know that's going to work both ways. And then with the LCD, you're going to multiply every term, so all three terms, by that LCD. And that'll allow us to solve it correctly. Get a big number here. We multiply the -45 to the numerator and divide it by 9. We'll be left with just this 5x. And a similar thing will happen over here, where 45 divided by 5 is 9, so we're just left with 9x. We'll add a 5x to move it to the other side. Now we just divide by 14 to get our answer. And you can just use your calculator to see this will be 135. That's how you solve the equation with the LCD method. Alright, for this problem, first we need to write the values that make the denominator 0, and then solve the equation. So what it's wanting us to do by first writing the values that would make the denominator 0 is what we're finding are, they're called restrictions. And these are values for x that we cannot put in the equation because we can't divide by x. So anything in the denominator that would end up making this 0, we cannot have. So in this case, we're going to see the only restriction is when x is equal to 0. So right here and right here, if we put in 0, the denominator is going to end up 0. So that's my restriction, x cannot equal 0, and then we just have to do the LCD again. In this case, we can see we can multiply the 5 and the 2 and get a 10, but we also have an x on our denominator, so 5 times 2 times x would give us 10x as our LCD. I'm going to multiply it to every term. And then the x's cancel out here, so we have a 90. Here we get 80x. Now we just need to shuffle some things around. We'll get, if you don't understand what I'm doing here, I did this in the previous problems where I just subtracted 90 and put it on the other side, and I subtracted negative 24x and put it on the left hand side. And I use divide by 56. This is our final answer. Alright, for this next problem, we have a lovely word problem. It says, a train ticket in a certain city is $2.50. People who use the train also have the option of purchasing a frequent rider pass for $15.75 each month. With the pass, each ticket cost is only $1.75. Determine the number of times in a month the train must be used so that the total monthly cost without the pass is the same as the total monthly cost with the pass. Okay, so when we see, it's good to sort of digest information. See the same, I'm thinking like an equal. They're equal to each other. It's going to be good to highlight the cost. So this costs that much. We have the frequent rider pass is that much a month. So that's just that flat cost that month. And here's another each ticket cost. Okay, in this case, we're going to make x be the number of train tickets bought in a month. And then over on this right side, we'll work, this will be the no rider pass. On the other side of the equal sign, we'll have the rider pass. The no rider pass is just simply I'll draw the equation now in green, make it a little easier to see the difference. It's just going to be this 2.5 50 times x, because x is the number of train tickets bought in a month. We're going to do our equal. On the other side, they have to pay that one-time fee of $15.75. Then, for every ticket, it's $175 times x. And now to find when the costs are the same, we're just going to need to solve for x. So we'll subtract 1.75x to the other side. And now we need to get rid of this. So we're going to divide by 0.75. If you just punch that in your calculator, you're going to be left with 21. So to take 21 times, so that would be the same cost. Onto a similar type of question. After a 16% price reduction, a boat sold for $26,040. What was the boat's price before the reduction? And we can round to the nearest cent. So the final cost that we see is the sales price. But to get the sales price, you're going to need the original price and I guess some sort of, we'll call it the reduction or discount, whatever you want to call it. And it seems like we're solving for the original price, so that will be our x. The reduction is 16%, so turning that into a decimal, we'll have 0.16x. And then we're also given the sale price. We'll just simplify these two like terms right here. And you can think of this as like 1x, which will then give us this. Now just divide to get to the other side. Plug into your calculator and round to see that x is going to be $31,000 would have been the original price. All right, looking at the next problem. You inherit $10,000 with the stipulation that for the first year, the money must be invested into two stocks, paying 6% and 11% annual interest respectively. How much should be invested at each rate if the total interest earned for the year is to be 800? Okay, so to do this problem, we're going to need to take the interest from the 6%. We need to add it to the interest from the 11%. That's going to give us the total interest. So taking the 6% and converting into a decimal, we're going to get 0.006. And it's going to be multiplied by x. And x is just our dollar amount. Now, the one that gets a little more tricky is the 11%. So the 11% in decimal form looks like this. But because of the stipulation, we need to subtract this 10,000 amount. And afterwards, it's going to equal the 800. So starting out like previous problems, we're just solving for x. So we'll multiply the 0.11 into the parentheses. Now we'll just combine these two common factors. We'll subtract 1,100 to the other side, trying to isolate x. Now we just divide. Use your calculator to see that x is going to be $6,000. And that's going to be the 6,000 in the 6%. And then to find out the 11% value, we got to subtract from the original inheritance up here. Sort of similar to this piece of the equation in here. So we give us this 4,000 is what's in the 11%. Alright, now for these questions, we need to perform the indicated operations, and we gotta write the results in a standard form. So, starting out, we have a negative in the square root, and we can't have that. So, we need to remember that square root of -1 is equal to I, and we're gonna work with that. So this negative, the square root of -36, we can just change into 6I. And that's because the negative in there, we turn into the I, and then 36 is just 6 times 6. So we simplify that. We do a similar thing here. Change this to 4I. Because 16 is 4 times 4. So we can simplify it, and then the I to get rid of the negative. Multiply this out, we'll have 30I plus 12I. And simplify, and we have 42I. Perfect. Looking at number 4, add or subtract as indicated, and then write the results in a standard form. So first things first, just for simplicity's sake, we're going to multiply these negatives. You can think as like -1s that we can multiply in, so we can distribute the sign, make this easier. So the 6 stays the same, but we'll get a +3, a +2i, a +6, a +6i. Then if you just simplify all these, you can simplify it into our standard form, 15 plus 8i. Next, find the product and write the results in standard form. To do that, we're just going to distribute, multiply this -2i into both these terms, which will give us a -8i squared plus 10i. And we got to remember, if I equals -1, the square root is just the square, not the square root. So if we square I, we'd get rid of the square root and be left with just the -1. So in this case, it would turn to this, leaving our final answer to be 8 plus 10i. Lastly, number 7, we divide and express the result in a standard form. So here, we're going to use something called the conjugate, which we can use to help simplify. So looking at the 3 minus I in the denominator, the conjugate is just going to be the opposite sign. So the conjugate of 3 minus I is 3 plus I. And we're going to turn it into a fraction. So what we're going to do is we're going to multiply the 10i minus, excuse me, we have 10i over 3i, and we multiply it by 3 plus I, 3 plus I. And we'll multiply that out. And in the numerator, we're going to get 30i plus 10i squared. In the denominator, we have to FOIL it. You'll get 9 plus 3i minus 3i minus I squared. We know these will cancel out. Remember that I squared is just -1. So we can simplify which this will just become plus 1. Oh, my eraser. Because minus a negative just makes it plus. We have 30i minus 10 over 10. And then, sorry, I'm kind of running out of room right here. So I'm just going to work to the side. We need to simplify it and split the fractions. And then if we divide, we can simplify one more time. And we'll be left with 3i minus 1. And then the standard form, we need to have the constant first. So we'll just flip the way this is ordered to negative 1 plus 3i.